right, as we get started today, we're going to begin with our first speed test of the fourth quarter. If you would open your speed drill booklets to page 20. Open your speed drill booklets, if you would please, to page 20 and to speed test 41. Speed drill number 41. We've been working a lot with these signed numbers. That's what the speed drill is, signed numbers. Now, I do want to caution you, 7, 8, and 9, look at those three. Class, what are we supposed to be doing on 7, 8, and 9? Multiplying. Sometimes students see it and they're doing addition and subtraction on the first problem, so they're still thinking addition, okay? Make sure you multiply when they're up against each other on 7, 8, 9. And then we've got a little bit of notation there with some exponents and even a root. We've done some stuff with those in the past as well. You'll have 2.5 minutes for the speed drill, which for this type of speed drill is plenty of time, so don't rush it. If you finish early, go back and check your answers. 2.5 minutes, and you may begin. It's kind of warm in here, isn't it? Elaine wants you jacket.
No.
Wait. She's just complaining it's cold. It's not that cold though.
My jacket will concede.
All right, all of you were done about 30 seconds ago. Most of you were done about a minute and a half ago. Like I said, plenty of time for this first speed drill. Maybe a little too much time, but whatever. We'll stick with what they have on here as 2.5 minutes. Exchange, if you would, please. With the person behind you, person in the back, bring yours to the front. Exchange with the person behind you, person in the back, bring yours to the front. And if you would, sign your name as grader next to where it says speed test 42, there at the bottom of speed drill 41. Sign your name as grader. Right next to where it says speed test 42. These are going to be 6 points each. 6 points each. All right. I'm going to go across the top row. I'm going to read each answer once, so listen carefully. Okay, cross it out if it's wrong. Leave it alone if it's correct. Number 1 is 1. Number 2 is 6. Number 3 is -12. Number 4 is -3. Number 5, -1. Number 6, 11. Number 7, -30. Number 8, +32, or just 32. Number 9, -60. Number 10, 4, or +4. Number 11, -9. Number 12, -4. Number 13, 10. Number 14, 25. And number 15, 32. All right, figure the total number wrong, multiply by 6, and subtract from 100. Total number wrong, multiply by 6, subtract from 100. Do we need one repeated? Okay, so multiply by 6, subtract from 100. Put the score in the score blank if you would, please. And then also, don't forget, on the score page, 6 points each, on the score page, right next to where it says speed drill 41, go and put their score on this speed drill. All right, put the score in the score blank. Return to the owner, if you would, please. Once you got the score written both places, return it to the owner. Person in the front, take it to the back. Person in front, take it to the back. And let's take a look at our scores. Were there any, still getting a final grade on there, hurry it up please, there we go. Were there any hundreds today? Any hundreds today? All right, a couple of you. How about 94s? You just missed one. All right, that's really good. How about 88s? Just missed 2. Still really solid. 82s? Still stayed in that B range. All right, any questions on those? Any questions on those? Going once, questions. Twice on questions. Going on questions. All right, pass those forward if you would, please. Pass them forward. Have your books out. Just keep them closed on your desk for now. We're going to review some things we talked about over the last couple of days. And we said that if we want to know how many possibilities exist in an uncertain situation, how many possibilities exist in an uncertain situation, we're talking about the total number of blank. What's that term that refers to a possibility, Ben? An outcome. And we said that each choice that relates to a certain number of outcomes can be referred to, Bryson, as an event. So we said if we're going to, I don't know, maybe we're going to do some skills test in volleyball. And say, all right, go to the volleyball bag, pick one out to use for the skills test. Has anyone noticed how many volleyballs we have? 4, right? So that means there's 4 possibilities. But if I also say, all right, grab or pick a corner of the field to go to, and we're going to go to a certain corner of the field to do this skills test. Well, how many corners of the field are there? 4 corners. Now, a regular PE field has a lot, it's weird shape. But anyway, go to a corner, right? So there's different possibilities that exist. So in that case, I said pick a volleyball, pick a corner. Well, if there's 4 corners and 4 volleyballs, what would I have to do to figure out how many possibilities there are then, class? Multiply, and we would get how many? 16. What's that called that says you just multiply all the possibilities of this event or all the outcomes of this event times all the outcomes of the next event? What's that called? Joel? Probability. Not the total number of possibilities, but Kirsten?
Fundamental counting principle.
There we go, the fundamental counting principle. Now, probability would be, Joel, if I said, what's the probability that Joel picks volleyball C and corner 2? Well, that's 1 out of the 16 possibilities. That's the likelihood that an event occurs. Does that make sense? What do we call the likelihood of an event occurring? He said it a moment ago, class.
Probability.
Probability is the likelihood of an event occurring. And we said there's different properties to probability. We said a probability can never be greater, class, than 1, nor can probability ever be less than 0. Because if something is absolutely certain, it's definitely going to happen. One day Jesus Christ is going to come back. He's going to rapture us up. We're going to live in heaven with him if we're saved. That is definite, certain. The probability there, class, is 1. The probability of an impossible event, that man can somehow resist the work of God on this earth. He tries. God gives some latitude, but ultimately God's going to be victorious. So the probability that man wins out, class, that is 0. If it's impossible, 0 probability. And all probabilities have to be somewhere between 0 and 1. 0%, 100%. Also, if we were to take a particular situation and we were to say, okay, what's the probabilities of this, this, or that? Well, all the probabilities in a particular situation have to add up to what, class?
1.
Have to add up to 1, right? So we can't have a 30% chance of this happening and an 80% chance of that happening and 24% chance of that happening. If it's all the same scenario, right? Like if there's airheads in the mug over there, it's like, well, the odds that Corey wins and he chooses a white mystery is 50%, and the odds that he takes a cherry one is 38%. The odds that he takes a blue raspberry is 40%. Wait a second, that's bigger than 1, right? That's bigger than 100%. You can't go bigger than 1. All probabilities have to add up to 1. Page 260 in your textbooks. Let's practice with this. We talked about this at the end of the hour yesterday. It's not a real challenging concept, but you want to make sure we talk it through and see how the book will present some of these possibilities. Page 260, we skipped these problems in the homework a couple of nights ago. And so let's come back and look at them now, saving them for once we talk about them, talk them through. So page 260, and notice they give us options on each set of probabilities. Either the probabilities is valid or it's not valid. If it's not valid, they want us to give a reason. Either one of the probabilities is not between 1 and 0. Right? It's either negative, it's bigger than 1, or the sum of the probabilities isn't 1. Or potentially both A and B. Though usually if I get to letter A, why would I even bother adding them up? Let's be real, right? Like, if I can see that one of the probabilities is wrong, I'm not going to add them up because I'm lazy. So number 13. If we look at those probabilities on number 13, there's a negative 45% chance, there's a negative 22% chance, there's a negative 33% chance. Is that a valid set of probabilities, yes or no? Luciana?
Yes.
Wait a second. You're one of those girls who tells the guys there's a 0% chance of you or a negative chance of you going out with them. Technically, no. The worst you can give a guy is 0% odds. Can't have negative probability. In fact, as soon as we read that very first one, like negative 45% chance. No, you can't have negative any chance, right? So no, not valid for that reason. How many recognizing the negatives says, no, you can't have that. Okay, hopefully we see it now. All right, looking at number 14, 19% chance, 63% chance, or 18% chance as the three possibilities that exist for these three things. Well, individually, do those probabilities look okay, class? Yeah. So now we have to test what? We have to go the extra mile and actually add them up. And do they add up to 100% or to 1? Yes or no? Ben?
Yes.
Yes. So we would say that that set of probabilities is valid. It is a valid set of probabilities there. Number 15, 2 to 5 chance, 7 out of 20 chance, or a 1 to 4 chance. Are each of those individually potentially valid probabilities, class? Yes, there's no negatives, and they didn't do like a 23 out of 20 chance. That would be impossible, right? So now what do we got to do? But in order to add them up, we got to have a common denominator. Or technically, we call it a common consequent because these are ratios. What is the common consequent or common denominator, class?
20.
20. So we're going to keep the 7 to 20. Let's change 1 to 4 out of how many to 20, class? 5 to 20. Okay, and then the 2 to 5 becomes how many to 20? 8 to 20. Okay, now we can add these probabilities up and see, is this a valid set?
No.
Yes. 8 plus 7, 15 plus 5 is 20. It adds up to 20 out of 20. That's a full 1, which is what it has to add up to. So yes, number 15 is a valid set of probabilities. Does that make sense? At your seats, you check number 16. At your seats, check number 16. Is that a valid set of probabilities? Michael, you good to go? Oh, maybe I'll go.
Well, please ask the pastor about something.
Okay. My worst case scenario, we leave you out of the picture and we forget all about you. Just kidding, we would never forget you, Michael. All right, how many look at these and say, man, one of those probabilities is crazy. You can't have one of those. I'm not looking at that. 2 to 7, 1 to 3, 3 to, those all sound valid. So if we recognize they sound valid, that means we have to do what? Add them up, and we need a common consequent, technically. What is the common consequent?
21.
21. So we should have, what is that, 6 to 21 for the first one. Check your work. Should have a 7 to 21 for the next one, and 9 to 21 for the last one. What does that add up to, class?
21.
23 out of 21. Wait a second, class.
No.
Not valid. They all look good, but they don't add up to the right thing, so number 16 is invalid. How many realize reason B, the sum of the probabilities, it wasn't 1. It didn't add up right. All right, go on to number 17. Number 17. Valid or invalid, and why, if it's invalid. Obviously, if it's valid, you don't know why. And I'm seeing some quick hands, and why should I see some quick hands, Joel?
Because it's more than 1.
One of those probabilities is 124%, right? 1.24. You can't have a 124% chance something happens, right? No, that's impossible. So how many realize, yeah, can't have something over 1? All right, go on to number 18. Number 18, is that a valid set of probabilities or is it invalid? Some quick guys in the back there, and a quick guy up front. Several quick students now all over the room. All right, Griffin, valid or invalid?
Valid.
Valid. Every one of them looks good, and they add up to 32 out of 32 chance. It's a valid set. How many realize it was a valid set of probabilities? Nothing wrong with those odds at all. All right, number 19. Number 19. Is that a valid set of probabilities? If there were 4 different things that could happen, could you have chances of 1 to 20, 1 to 10, 1 to 5, and 1 to 2? Can you have those probabilities? Maybe they take the 4 teams that made the college football playoff last year and say, what are their probabilities of winning this whole thing this year? Well, Michigan lost a ton of people. Maybe their odds are 1 to 20. And who else was in the playoff? Alabama, they're rebuilding with a new coach. Maybe they're 1 to 10. Who else was in there? Texas, they got the quarterback back. Maybe they're 1 to 5. And they probably actually put Georgia as 1 to 2, honestly, even though they didn't make the playoff. But anyway, I digress. Is that a valid set of probabilities, yay or nay, Jalen?
No.
Nay, 'tis not. All of them sound good, but they don't add up to 20 out of 20. Number 20. Again, think of these as percents. They're written as decimals. You can think of them as percents. It's just lazier to type down. Oh, a lot of quick hands. Class, what's the dead giveaway? Now, you can't have negative odds. So yeah, number 20, definitely not a valid set of probabilities. Do we understand what makes valid versus invalid probability? We all good with that? All right, didn't think that was too hard, but did want to review it with you. Page 258, flip back 1 page. Page 258, at the bottom of the page, I want you to do numbers 55 to 58 using that fundamental counting principle. 55 to 58, they're at the bottom of page 258. Use the fundamental counting principle to figure out how many possible outcomes we could have in each of the described situations. I'll go and turn off the blizzard for you.
Yes.
When you finish all 4, stand if you would please. Once you're done with all 4, go and stand beside your desk. Well, that's a question you're going to have to figure out, right? Joel is finished. Jalen right behind him. Elaine right behind her. Corey. see. And let's take a look at these. We will give Joel first crack at this. Joel, we got a combination lock with 4 digits on it. So this is like a briefcase lock like we talked about. You can have any of the digits 0 through 9. How many different codes could you program that lock to have?
6,561.
Oh, I know what you did. You said there's 9 for each of them, but 0 through 9. 0, 1, 2, 3, that's 10 for each of them. But your thought was good, just, oh man. Let's see, second was, Jalen, what'd you have?
1,000.
You do indeed. Oh, okay, third was Elaine.
10,000?
10,000. You missed a 10 in there. All right, so we'll stick with Elaine now. 10,000. 10 for the first number. 10 for the next number, 10 for the next number, 10 for the next number. You multiply them all together. Number 56, local community college has 12 majors and 14 minors. Each plan of study includes a major and a minor. How many possible plans does the college offer? For instance, when I went to college, I was math education major. I was a physical education minor. So most of my classes I took were the math, and then I took a whole bunch of PE classes as well, so I'd be equipped to teach both. Well, how many major minor combos? Well, I could have been math ed and science ed. It could have been math ed and history. It could have been math ed and English. I picked math ed and PE, phys ed. How many different plans of study, Elaine?
168.
168. We take the 12 majors they have times the 14 minors they have. Gives you 168 different ways you could potentially plan your college education. Number 57, each student at an academic competition will be given a randomly selected challenge, a riddle, a math problem, and a foreign language question. All right, there are 9 different riddles they could give you, 20 different math problems they could give you to work, and 8 different foreign language questions available. How many different challenges could they produce? So each student only gets 3 questions. That's weird. Anyway, how many?
1,440.
Good. 1,440 different 3-question challenges that they could give to these students. And for the candy, number 58, using the English alphabet, find the number of consonant, vowel, consonant outcomes. For instance, if we wanted to write Corey's name, the first 3 letters are a consonant, a vowel, and another consonant, right? For some of you, that's the case, like Luciana, L-U-C, right? Ben, B-E-N. Okay, but not all are this way. So the question is, obviously we don't necessarily get full words for this, how many consonant, vowel, consonant outcomes are there?
I think this is wrong, but 110.
Oh, more than that. All right. So, fourth, after Elaine was Bryson?
No, it was Luciana.
Okay, Luciana?
Luciana and then Bryson.
You're perfect so far?
Yeah, but I think I got it wrong.
What did you have?
105.
Oh, it's no. Are you perfect so far?
Yes.
Also got 105. Let's see, fifth, sixth was Corey. Okay, Corey?
3,380.
No, but you're closer. Michael, I think, was our last finish. We're here. Yeah, I think we've got everybody else. Yeah. Michael?
2,420.
You're really close. All right, man, no kidding, that's close. How many total letters are in the English alphabet class?
26.
26. Now, how many vowels?
5.
5 vowels, which means how many consonants?
21.
21 consonants. Now, they want a consonant, vowel, consonant. So that's 21 consonants times 5 vowels times another 21 consonants. That's what we would have had to multiply. So you got it?
Yeah, 2,205.
2,205 is our correct answer. All right, I'll tell you what, we'll give you another shot at some candy here. Before we do, though, any questions on these problems? Any questions on these problems? All right, so we understand how to do these counting principle things. We're good to go? All right, now let's look at numbers 59 to 61 at the top of the page. 3 more questions dealing with probability. We want probability notation first, then the answer as a reduced ratio. Do 59 to 61 at the top of the page. Holy Toledo. I think it was a 1, 2, 3 that I saw. 4. Are the water bottles okay?
Yeah.
All the people okay?
No.
Now if you see, keep working, because they might have gone so fast they messed up. So you keep working and See if you got them. We'll see. Corey, 5th. And Luciana, 6th. Okay, let's take a look at these. Have a seat. All right. Middle school has 60 students. It's got 6th graders, 7th graders, 8th graders. They were kind enough to give you the 60. And so one student will randomly be chosen for something. I don't know if they're going to send this student to, I don't know, some convention or whatever. What's the odds they pick a 6th grader? Well, again, realistically, why would you send a 6th grader if you've got 8th graders you can send, right? I mean, let's be real. But anyway, but, you know, if it's totally random, right, totally random, it does say randomly chosen. Well, first of all, what would we use for probability notation for a 6th grader? Elaine?
It's like P, whatever that is.
Parenthesis?
Yeah. 7th parenthesis.
For the probability of a 6th grader?
6, sorry.
And what did you put for your answer for the probability of a 6th grader?
1 and 4.
1 to 4. 15 to 60, but it reduces to 1 to 4. All right, for the next one, we need the probability of a 7th grader. We should write
P, parentheses, 7th grade, equals 5 twelfths.
5 to 12 is our correct answer, all right? And then the next, for the probability of an 8th grader, we write
P, parentheses, 8, parentheses, equals 1 and 3.
And it is 20 out of 60, does reduce to 1 to 3. Got them all. How many also got them all? Just not quite as fast as Elaine, though. It was really tight there in those first 3. It was kind of like doing the wave at a basketball game, you know? All right, anyway, except they weren't raising their hands at the same time. All right, questions on probability. We feel good about this. All right, go ahead and clear your desk then, except for a plain sheet of paper and a pencil. Plain sheet of paper and a pencil. Well, let's take a quiz over this. Feels like we've got it nailed down well. Let's start the 4th quarter off with 100, shall we?
Yeah.
Plain sheet of paper, pencil, everything else away. If you're watching on YouTube, this is quiz 26. Quiz 26 that they will be taking. All right, pencil, paper, everything else away. Quiz is being stuck together. You know what? Forget it. Give you that one. Well, the girls fight with the stuck ones. All right, first and last name in the name spot. Today's date in the date spot. It's okay, they unstuck as they were being passed. All right, first and last name in the name spot. Bless you. Today's date in the date spot. Today is 3/28/24. 3/28/24. Today's date. I got some questions for you on numbers 1 through 4, so read each question carefully and answer each question. Be sure to use your cover sheet as you work. For numbers 5 through 7, find the total number of outcomes. I would suggest you show your work, just in case brain glitches and you do a process wrong in your head. Show what you're doing. It would be my strong suggestion, so I can give you partial credit on 5 through 7. And then numbers 8 through 10, answer those questions about... it's kind of a nutty question, but answer those 3 questions anyway. Again, believe them as reduced ratios. You may begin. Sorry. This isn't a comedy channel. You don't come here for good jokes. Although you don't have to hit the dislike or thumbs down button just for that joke. Come on now, people. Use your cover sheets as you work. finish turning paper over, sit quietly. What we were doing earlier. That's why we do class. And then we figure out what we do in class. So we've got a couple more minutes to be finishing. If you're already finished, just cover your paper up, sit quietly, wait for the others. Rest your head if you want to. Just don't snore. Don't overthink it now. Just a little bit longer than finishing. Yeah, number 4, when it says must happen, that means it's definitely going to happen. It is certain. That's what it means when it says it must happen. It's definitely going to happen. It is certain. Just a little bit longer to be finishing up. Pass those forward if you would please. Pass those forward if you would please. Take your books out. Open to page 260. Pass those forward if you would please. Open up your textbooks to page 260. We will take a look at these tomorrow. Get those graded and see how you did on those. But now we want to continue building on this idea of probability. And so far we've looked at the probability of one particular selection, right? It's the probability of this. Right, we said if one of these guys is going to be named Class King. All right, well, each guy has a 1 in 6 chance of being named Class King, right? And what does that come with? No perks at all, I promise you. But anyway, 1 in 6 chance. But what if I said, what's the probability Corey or Ben ends up as class king? Well, see, Corey's got a 1 in 6 chance, right? And Ben has a 1 in 6 chance. So technically now, by including both of them, do you see how I've increased the odds of picking who ends up being class king, right? For instance, I mentioned this once before, but if I'm a Colts fan and the only outcome that will make me happy is Colts win Super Bowl, well, purely statistically speaking, if we knew nothing about football except that there are 32 teams, you would say there's a 1 in 32 chance that happens. But if I have a second team that I kind of cheer for too, remember we said, well, that increases the odds of that happening. These are what we call this is what we call a compound event. Look at that at the bottom of page 160. A compound event is composed of 2 or more separate events. A compound event is an event composed of 2 or more separate events. And they list the idea of Juliet, who's playing a board game. She's rolling dice, and so that we don't have to look at a whole bunch of dots. They actually wrote the numbers on the dice, but real dice don't usually have that. And she needs to roll either a 10, 11, or 12. Okay, that's what she's hoping for, a 10, or an 11, or a 12. Well, there's 3 different ways you could wind up with a 10. There's 2 different ways you could wind up with an 11. There's 1 different way you could wind up with a 12. She's happy with any of those. So by being happy with either a 10 or an 11 or a 12, we're going to add the probabilities together. At the bottom of the page, if you write this, the probability of this or that can be found by finding the probability of this plus the probability of that. If you're trying to find the probability of either this or that happening, well, find the probability of this happening, find the probability of that happening, just add them together. Another thing to write down and put a star next to this, or means add. When we work with probability and we see the word or, it's telling us to add. Now, that's only in probability, okay? That doesn't apply to other realms of mathematics, okay? But in probability, or means add. Because as soon as you give yourself a second choice, you increase your odds. Does that make sense? Right? Look, for instance, if you would, at the example problem on page 261 now. You got a little spinner there, right? And it says, what's the probability of spinning a 1 or a 4? Well, notice the notation. They said the probability of 1 or 4. That's how we would write the probability notation. But remember, or means add. In probability class, or means add. So that means we're going to find the probability of spinning a 1 and the probability of spinning a 4, and we're simply going to add those 2 probabilities together. Well, all the little spaces are of equal size, so unless it's rigged with a magnet or something, class, the odds of spinning a 1 is going to be, the odds of spinning a 1 is going to be 1 to 6, right? That's one number out of 6. Well, similarly, the probability of spinning a 4 class is going to be 1 to 6. But we're going to add those 2 probabilities together. We get an actual probability of 2 to 6, which we'll reduce to, say, 1 to 3. Another way to think of it is, this is 2 numbers out of 6. Got a 2 to 6 chance you're happy with the spin. Make sense? Look at the next one. What's the probability of spinning a blue area, or a 2, or a 3? Look at the way they wrote the probability notation. P, and then in parentheses, blue, or 2, or 3. See that? Well, that means we need to find the probability of blue.
Mr. Nadasky?
Yes, ma'am.
Can we have Michael come to the office, please?
Yes, ma'am.
Thank you.
So we find the probability of blue. Class, how many blue spots are on that spinner?
2.
2 out of how many total spots? 6. Okay, next. Probability of a 2. How many 2s are on a spinner, class?
1.
1 out of how many? 6. All right. And then it says the probability of a 3. Well, how many 3s are on a spinner?
1.
1 out of 6. So the probability of spinning a blue or a 2 or a 3 is going to be all 3 of these added together, because or means add. We're talking probability. What's our probability, class?
4 to 6.
4 to 6, what we reduce it to say? There's a 2 to 3 chance we're going to be happy with the outcome if for some weird reason we just want to spin blue or we want to spin a 2 or a 3. Seem pretty easy? Still not blowing anybody's brain. Just add the individual probabilities together. So, turn the page. Page 263. Look at page 263. We got another spinner. This time, it goes all the way up to 8. And look at problem number 1. It says, what's the probability of spinning a 3 or an 8? Well, how would I write the probability notation for spinning a 3 or an 8? Kirsten?
P parentheses 3 plus P parentheses 8.
Okay, there we go. What I think they were actually looking for is you to really actually write P3 or 8, but I'm lazy, so I'm actually fine with you starting here. P3 plus P8. Does that make sense? Probability of spinning 3. Since it said or, we're going to add the probability of an 8. Well, class, how many 3s are on the spinner?
1.
Only 1. So that's 1 out of 8. How many 8s are on the spinner, class? 1 out of 8. So what's the probability of spinning a 3 or an 8? Anyone?
4.
1 to 4. 2 to 8, but reduces to 1 to 4. Seem pretty easy? Look at number 3. The probability of spinning a 1 or an even number. How would I write that probability notation, Griffin? For number 3.
P parentheses 1. So, P parentheses even.
Okay, there we go. P1 and P even, but since it said or, we need to
Add.
So P1 plus P even. Everyone see that? Well, how many 1s are on the spinner, class?
1.
Out of
8.
8. How many even numbers are on the spinner, class?
4.
Out of
8.
So what's the probability of a 1 or an even, class?
5 to 8.
5 to 8. There's a 5 to 8 chance you get a 1 or an even. Making sense? We're tracking what we're doing. Okay, turn the page. And read that next one for us, if you would, Jalen.
Each row of letters is in an
Each of the letters.
I was reading.
Or each of the 11 letters.
Each of the 11 letters in the word mathematics was written on a separate piece of paper and placed in a bowl. What is the probability of drawing blank?
All right, so we got mathematics. That's a nice long word. Aren't you glad we just call it math class instead of mathematics class?
Yeah.
Though technically the title of the class is Intermediate Mathematics, which is really long. But anyway, and it says, what's the probability, it says, of, for number 5, the probability, class, of an A or an M? All right, well, what that means is we need to first, class, find the probability of A, and we need to find the probability of M, and do what with those two probabilities? Add them together. So, remember, there's 11 total letters in this word. How many A's are in this word, class? 2. So the probability of just an A would be
2 to 11.
2 to 11. The probability, well, how many M's, class?
2.
2. So the probability of an M is
2 to 11.
2 to 11. So the probability of an A or an M would have to be, class?
4 to 11.
4 to 11, because or means add. There we go. So getting the hang of it? You do number 7. The probability of a vowel or an H. The probability of a vowel or an H. It's like going back to kindergarten. What are those vowels again? We are on number 7. Michael, we've got the various letters of mathematics. We said, what if we took each letter on a piece of paper, put them in a bowl, and reached in and drew something out? What's, first of all, the probability we would draw out a vowel? Well, class, how many vowels are in the word mathematics?
3.
4.
A-E-A-I. 4 vowels out of how many total letters?
11.
11. What's the probability of an H, class?
1.
1 out of 11, right? There's only one of those. And so the probability of either a vowel or the letter H, class, is 5 out of 11. Because there are 5 such pieces of paper that would fit those descriptions. How many have 5 to 11 for your answer? Let's take a look at numbers. This next set there. A deck of cards has 1 card for each of the numbers 1 through 10. So pick a card, any card, and there's just numbered 1 through 10. What's the probability of an 8 or a 5? At your seats, do number 9. What's the probability of an 8 or a 5 being a card that is drawn? Pick a card, any card. The odds of getting either the 8 or getting the 5 are what? Bryson?
For 1 to 5.
1 to 5. 2 out of 10. There's a 1 to 10 chance you get the 8. There's a 1 to 10 chance you get the 5. 2 out of 10 or 1 to 5 chance having the same answer. Number 11, the probability you get an even number or a 3. The probability you get an even number or a 3. That's your seats. Number 11. Pick a card, any card. Ooh, I really want to get an even number. Or a 3. I like 3 too. What's the odds you're happy with the outcome? Random as that is. And Ben, you got it? What you got?
2 to 5.
Not 2 to 5. How many even numbers are there? 1 and 3, 1 to 10. How many even numbers are there?
5.
5 of them. That's 5 out of 10. And then how many 3s are there?
1.
1 to 10. So we should initially get
6 out of 10.
6 to 10, but that doesn't reduce to 2 to 5. Divide out the 2, it reduces to...
3 to 5.
There we go, 3 to 5. How many had 3 to 5? On number 11. All right, number 13, we've got a stack of arithmetic flashcards again. We had one like this the other day. There's 20 addition cards, 35 multiplication cards, 10 subtraction cards, 5 division cards. Number 13, what's the probability of getting either multiplication or division? What's the probability of getting a multiplication card or a division card if you draw at random? Ooh, what do you have to find first, class?
The total.
The total number of cards. Stay with me, we're almost done. The total number of cards needs to be found here. How many cards are there, class? 70 cards. Okay, how many of them were multiplication?
35.
How many were division?
5.
So what's the odds of a multiplication or division?
40.
40 to 70, which we'll reduce to say?
4 to 7.
4 to 7, and right below it, real quick, we finish up with 15. A division or subtraction at your seats. Division or subtraction. Division or subtraction. Subtraction. 10 subtraction. Where did it go? Did we get 15 to 70? Which reduces to anyone?
3 to 14.
3 to 14. 3 to 14 chance of a division or subtraction. Any questions on the or thing when it comes to probability? Seem really easy still. All right, not hurting anybody's brain here in the fourth quarter. Homework for this evening is to do page 270, homework 1 to 13. Page 270, the homework 1 to 13. Page 270, numbers 1 through 13. Have a wonderful rest of your day, and you are dismissed.
So do we